All right, hi there. So we are on our Unit 2 practice open response. This is for Unit 2 Part 2. You also will want to make sure if you have any of your notes out, that's a great idea. The learning targets were all for the quadratic functions. Just looking at one of the pages, depending on your teacher, it was either 2.6a or 2.7a. But again, it starts here. This is Part 2, and we're looking at different ways to solve a quadratic. Our first one was factoring, and then we did square roots, and we also did completing the square, and then the last one that we talked about was the quadratic formula. Again, this should be in your notes packets with examples of how to do each. We also gave you this little mini cheat sheet for your last quiz. So this is also a great note sheet to have out. It's got the 4 different types we focused on. But then we also had you guys talk about copying down the discriminant, which is part of the quadratic formula. And that will be on the back part of the open response. So this is also a very good sheet to have out to help you. So let's look at the very first one on our open response practice. So if you recall, we've got 2 things multiplied by each other because there's nothing in the middle. So what we're going to do is double distribute. Some people use the box method. Some people use double distribute. So I'm going to just do double distribute. 5 times 7. And then I get 35. And then 5 times, this is a positive root 3. And if you remember, you cannot multiply these 2 together because one is under the square root sign and one is a number by itself. So we just have to put, it's a positive 5 times root 3. And if you recall, that's how we do 5 times the square root of 3. We just write it like this. And then the other part, so looking at double distribute, I'm going to do the bottom now. I have a positive 3 times, a positive square root of 3 times 7. This is, again, we have a positive 7, the number goes out front, and then the square root of 3. We cannot multiply these numbers together. They do not have the same, one is outside of the square root symbol and one is inside, so we can't do anything with those. And then the last one, we have a positive square root 3. I'm going to write it off here to the side, times another positive square root 3. And if you recall our little trick, anytime we multiply the square root of something by itself, it becomes itself without the square root sign. And you can check that in your calculator too, because it becomes the square root of 9, which is just the number 3. Okay, so now that I did double distribute, I need to combine like terms. Combining like terms means only numbers can go with numbers by itself, okay? And then anything that has like a root attached to it, so the square root of 3, square root of 5, those can go together. Only the numbers out front, but the square root and the number under it stays the same. So let's look at, I've got 35. I always start with my numbers that are by themselves. This plus 5 square root of 3, this is a term, so it's not by itself. Plus 7 root 3, again, that's a whole term, it's not by itself, but I do have a positive 3 by itself. So if I take 35 and 3, I get 38. So that's my number out front. And then if I'm going to go ahead and take my numbers that have a similar square root. This is the square root of 3. This is the square root of 3. So that means I can combine the numbers in front. It's going to stay as the square root of 3 because these have to be the same to add or subtract. But I have a positive 5 and I have a positive 7. And then remember that square root of 3 stays behind it. So 5 plus 7, so that would give me a positive 12. And then remember the square root of 3, you don't do anything when it's adding. You just leave it the same. So that would be our final answer for the first one. So just make sure that you are following those rules. So I want you to try number 2 on your own. And then look at my work in however long it takes you. But remember, follow these rules again for the square roots. Okay? Okay, so looking at the work, hopefully yours matches to double distribute. And then that last one where we had the square root of 7 positive times the square root of 7 negative, we have to be careful here because remember one was a positive and negative, so it's a negative, but then anytime you times it by itself, it becomes just the number without the square root. And then I did the combining like terms, so 12 minus 7, that goes a positive 5, and then negative 4 plus 3. You can either leave it as a negative or you could put the negative 1. It doesn't really matter. All right. Hopefully you got that one right. If not, go back and give it a try looking at the work. So 1 and 2 are very similar because they're that multiplication where we double distribute and we have the square roots in there. So now we're going to look at the next type, which is where we double distribute, but we have those i's. And remember, you should remember anything with an I squared equals negative 1. So I wrote that over to the side. It's in our notes as well. We're going to go along doing it the same way. However, we need to take out any I squareds when we're done before we combine the like terms. So let's do the double distribute. So I'm going to do on the top 9 times 3. Okay, that gets us to 27. And then I like to do 9 times this negative 5, which would give me a negative 45, and then there's an I with it. And then now I'm going to go to the bottom, negative 2I times 3, so negative 2 times 3 is negative 6, and then the I stays with it. And then the other part, you have to be careful here, that's a negative 2I times a negative 5I. So a negative 2 times a negative 5 would give me a positive 10, and then an I and an I is an I squared. So that's double distribute. Now I have to get rid of any numbers that are anything that's next to an I squared. I have to multiply by a negative 1. So looking here, I have 1 I squared in this whole thing. And remember, an I squared becomes whatever that number is. So this is really 10 times negative 1, this whole thing right here. And then if I were to even simplify it farther, it would become 10 times negative 1 is actually negative 10. So I'm going to write it down there, and I'm going to get rid of this stuff. We've already fixed it. So you can rewrite it as you go along. I just like to cross it out. Once I put the negative 1 in there, and then I change the symbol, I have to make sure, don't carry the symbol with it. Make sure that if it's 10 times negative 1, it becomes negative 10. And then you can cross out all this stuff because we've already used it. So that just shows, just so you can see, we're only combining these like terms because we got rid of the I squared and we made it into a negative 1, and then we just did whatever it told us to do, which is multiplication most of the time. So let's combine like terms now. Remember, I like to start with just the numbers. So I have a 27 and a negative 10. So 27 and negative 10, that's going to get me a 17. And then I'm going to go for the negative 45I and negative 6I. So remember, we're going to add those two negatives together. That gives us a bigger negative minus, so that's 51, and then the I stays with it. These are just combined like term is add or subtract, so there's no more I squareds. We just add them together. And then this is our final answer for that one. Okay, remember this is standard form. This is like the A plus or minus the B times the I. So we have to have in that form. Okay, and we'll look at number 4. So you can try this on your own if you want and pause it and then just watch as I do the work. And if you recall, this is called a difference of squares whenever we have the same thing but a different symbol in the middle. So you might remember we cut off that middle term or it ends up disappearing, or you can just do it the long way. It does not matter. Okay, so you can either try it on your own or do it with me. So I'm going to do 3 and 3, which is 9, and I'm going to do 3 times negative I, which is negative, I'm going to put a 1 in front of it, negative 1I. I just like to have a number while I'm doing my work. It does not matter. Okay, next, bottom, I'm going to do a negative I and a 3. So that becomes a positive 3I. And sorry, this middle one should say a negative 3I. That should have been negative 3 times I. So negative 3 times 1 is negative 3I. And then the last two, make sure we have a negative I times a positive I, which gives me a negative I squared. So this one can get tricky if you don't think about it in terms of its sign. So a positive I times a negative I gives you that negative sign. So you do have a negative sign here. You have to keep that there. But we also have an I squared, which also equals so we have a negative times negative 1. So you have to be careful there. This is where these two can get tricky. So if I were to rewrite it, 9 minus 3I plus 3I, and then from here, remember, right here I rewrote it, I have negative 1, which is really a positive 1, because a negative times a negative undoes itself. And then here, remember what I said, difference of squares. We're going to have a negative 3I, which undoes a positive 3I. And then we have 9 plus 1, which equals just 10. So whenever you have this type of problem, you should know you're just going to get a one number answer, one term, because the two middle terms undo each other. Okay, so this was that first learning target, the complex numbers. If you need to go back and look at these again, you have to remember all these rules. There's a lot of them in terms of what you're allowed to do with multiplication and division and adding and subtracting. Okay, so now we're going to look at the next target, which is solving the quadratics. We gave you guys 4 different ways you could use, and so I'm going to do a couple different ones. On the quiz, we told you which ways to do on the test. We give you hints, but again, you're allowed to use the way you prefer. This little half sheet is a great tool because it has the different reasons why we would use each one. Remember, we think factoring is usually the easiest, but you have to make sure that the C is a 0 or it's easily factorable. And then that chart also in your big note packet. We have the charts on every single page of the notes. So you can even see problems worked out if it helps to see. Okay, so we would make sure you have those out. Let's look at number 5. I want to look at solving this one. So I noticed right away that I could probably put this using either if I go the other way, if I rearrange things and put it in standard form, I can actually use my quadratic formula, that negative b plus or minus. That one I like to use because it works well with smaller numbers. It also does well when we have, there's no number in between here, and we can easily change this to a standard form. So I just rewrote this one. So it's in standard form because, again, I can take this to the other side and it makes it in standard form for us. So then we can identify our A is 1, our B is this positive 6, and our C is a positive 81. So using our formula, again, we're going to do that quadratic formula, this whole entire thing, plug numbers in. So I have my negative b, so negative b is right here, and then I have plus or minus, and then I'm going to do the square root, and then I have to do, remember underneath there I have b squared, which is 6 squared, minus 4 times a, which is 1, times c, which is 81. So I have to do all that stuff. And remember, just all this stuff under here I'll highlight it for you. This is called the discriminant. So sometimes we actually start off by finding this first, and then it makes it a little easier to do the stuff in our calculator, but it's totally up to you. And then we also have that's the discriminant, and then all of it is divided by 2 times, remember it's 2 times our A, which is 1. So again, if we were to go ahead, I like to find our discriminant first, which is this blue part. Okay, I'm going to find that and put it in here, just the blue part. So 6 squared, and then we have, excuse me, minus 4 times 1 times 81. If you put that all into your calculator, right, you get negative 288. That's just the discriminant part. So then again, we have, if you look at it, we want to make sure we have to take out, if that is going to be under a square root, we have to take that out. So that would actually be, we take the I out, and you have the square root of 288. And then you can factor from here. We can see what goes into there. I'm going to start with, I know 288, you could start with 2, but that would be kind of small. So I'm going to use 12 because I just know in my head 12 goes into those numbers. It's actually 12 and 24. Remember, to get that negative out, we have brought the I. So then I have 12, I have 2 and 6, I have 3 and 2. I'm going to circle 24. I get, let's do one that's a perfect, if there are any perfect squares that go into it. So I know 4 and 6. Well, 4 can come out. And 6 again is a 3 and a 2. So when I pull everything out, this negative on the outside, I end up with, I'm going to rewrite this part because this is part of the answer, negative 6. And then I'm going to do the plus or minus. And then this is where we go back to this negative 288, which would have been under here. And we pulled out the I, and then I can also see I have 1 pair of 2s, another pair of 2s, and I have, oh, sorry, that's a pair of 3s, and then another pair of 2s, which was that for that perfect square. So I have 2 times 3, which is 6, times 2, which is 12. So really, this becomes, when all is said and done, I've pulled out the on the outside, I pulled out the 12 because I have the 2 times the 3 times the 2 and an I, and I still have left over. So what I couldn't have pulled out here was just a 2. And then remember, we divide everything, and that's 2 times A, so that's just 2. So we can keep it in this format. That's okay so far. But if we needed to, we might have to go back and simplify it. Say if it's a, if it says make sure it's in simplest form or one of your answers over there. So just looking at this, I just want you to see that we would divide all 3 terms by the 2. So I would do negative 6 divided by 2, 12 divided by 2, and 2 divided by 2, which will give you the final answer. And I'll put it over here on the line so you look at it. So negative 6 divided by 2, I get a negative 3 plus or minus. So as you can see, I'm just taking that 2 on the bottom. And then here, I would have a 6i because I took 12 and I divided it by 2. And then again, so if I were to do, that would be root 2 just because it goes into itself once. Okay, so this would be our final answer. This is the best way to write it. If you got this far, this is great. You just need to simplify with whatever's on the bottom. Okay, so that was using the quadratic formula. Okay, so now we're going to problem 6. I kind of roped it off, you would say, so that you'd have more room and you can see. So I'm going to do this one. Looking at this, I can tell right away these numbers are a little bit smaller and they're easy to factor. If I were to bring this x squared and then bring the 5x to the other side, I'd have minus 5x in the middle because we want it in standard form. And then that plus 6 comes to the end, and you can do equals 0. I can think of possibilities in my head that when I multiply them together, I get 6, and that I can also add them together to get -5. Whereas the other one that I did when I had that 81, I couldn't in my head think off the bat, oh, what are two things that when you multiply is 81, but when you add or subtract, you get 6. I couldn't think of anything. That's why I went with the quadratic. So this one I could think of right away because these are easier numbers to factor. So if I look over here again, I want to factor what 2 when you multiply is going to give me a +6, and then when you add them, you get a -5, okay? So I'm just going to think of I'm going to start with 2. So 2 and 3, when you multiply 2 and 3, you do get +6. But you don't get so you have 2 plus 3, but you don't get a -5. So that tells me, since I get a +5, or that would give me a +6, when I add them, it would give me a +5. Sorry, that's supposed to be a 5. I want a -5. So I know I'm on the right track. So let's make one of these negative so that we will get the -5. So let's just see. I bet you if we do both of them negative, that's the only way to get a positive at the end. So if you remember that from Algebra 1, if you want a positive end number for your factors and your middle term is negative, they both have to be negative. So that'd be a -2 and a -3. So -2 times -3 is +6, but also -2 minus 3 is -5. So these are my two factors. So I would have an x, and then I would use -2 and an x and a -3. They have to be in that order, again, because when that back number here, when our constant, or c, is positive and the middle one is negative, you know you have two negatives. So then, again, you can either remember that little trick where set it equal to 0 and solve, or sometimes it's easy to remember when there's no number in front of the x. It makes it a lot easier to just make it its opposite. But I'll show you the longer way. So that's +2, +2. So x, 0 plus 2 is just 2. So x would equal 2. That's one of the answers. And then again, this one, +3, +3 cancels here. X equals a +3. So it could be both of them. Okay? All right, so now let's look at the next couple. Let's look at 7. Now, if you can tell from 7, it's in a certain format, right? We call that vertex form. And we also know when we see it in the square roots, can you guys see whenever you have this, that one side of the equation is in a perfect square, meaning this part right here? This could be a reason we use the square roots, okay? So we are going to do that because that's an easier way to use the square roots. It's just, there's a little hint for us. We see this part, and that should tell us, okay, let's use the square roots way. But again, if you like a different way, you can try it. It does not matter. I'm just going to go with what looks easiest. So for this first one, we just have to make sure, so we're going to take numbers to the other side. -18, -18. I want to get that square root part all by itself. So those cancel. I'm left with 2 times x minus 2 squared equals, and then 42 minus 18, we get 24. Okay? Just putting a line where my work is. So now, this is where we go in a little bit of different order. We can't touch that squared yet, but we can touch the 2. So instead of 2 times, what we would then do is we're going to divide both sides by 2. Divides by 2, and these cancel because that's what I'm dividing. So I'm left with x minus 2, and all of that squared equals, and then remember it's going to be 24 divided by 2. That'll give us a 12. Now we're almost done. We have to get rid of the squared. And so from there, we know that we can take this and we can square both sides by doing, undo the square by doing the square root of both sides. Square root. So if you look at that, we have, that goes away, and then we have, I'm going to write a little over here, x minus 2 equals, and then remember the square root of 12. We want to, square root of 12, we want to simplify it if we can. So I'm going to put it up here, and I know a perfect square goes into there, but you can do it on your own and bring out. But I know that it's 3 and 4. 4 is a perfect square. It's a set of 2's. So I can bring out, remember, when you square both sides, you want to have the plus or minus. And then I know when I bring out the 4, that's a set of 2's. And then I'm left with that 3 underneath, square root of 3. So then from here, we just take our 2 to the other side. So basically we have this positive 2 over here. So I'm going to do plus 2 and plus 2. And basically it cancels here. So x equals, and then the 2 goes in the front, 2 plus or minus 2 root 3. So you can go through and do 2 plus 2 times the square root of 3 in your calculator, and then you can do 2 minus, but this is good enough answer for us in simplest form. So this is good enough. Just remember, when you pull out a perfect square, you have to pull out that 2, not the actual 4. That one, this is where we get a lot of mistakes right here. If you know a perfect square of 4, well, you know it's the 2's that come out. All right? All right, and let's look at 8. So 8, again, this could be your choice. I'm looking at these numbers for 8, and I think to myself, this, if I move it to the other side, I would have an easy set of numbers to factor. So x squared minus 6x plus 9. I just think in my head, I know 2 things that when I multiply them, I'm going to get 9, a positive 9. That's going to also get me a negative 6. So that's why I'm going to choose to factor on this one. But again, use whatever one you want. So I'm going to have a positive 9, and then when I add them, I want a negative 6. So remember what we said about the other one? When this term is positive at the end, and if the x term is negative, we know we need 2 numbers that are negative. So in my head, well, 9, the 2 numbers that go in there, they're 1 and 9 or 3 and 3. So I know that 3 and 3 somehow is going to get me a negative 6. Negative 3 times negative 3 is positive 9. And then again, let's make sure, is negative 3 plus negative 3 negative 6? Yes. So this is the answer. There's nothing in front of the x, so we can do x minus 3, and then we have x minus 3. They're both exactly the same, so we know the answer is going to be the same for both of them. It actually ends up being x equals, and then remember, if you set it equal to 0 and solve, you just get the 3. Okay? And then looking at the last one, it's a story problem, but it's not much different than solving something that's not a story problem, because it just wants us to find the variable that's missing or the possible solutions. So it says a baseball player throws a ball and it falls to the ground. The ball takes, I should say the path that the ball takes follows a parabolic path modeled by, here's the model, okay, this f of t. How long until the ball hits the ground? So a hint is when we get to solutions, we want the positive answer. We can't have a negative amount of time right now. So we should know if we go to solve this, we have to try both solutions to see which one's going to give us a positive answer. That's the only real tricky part here, because technically this isn't a real difficult story problem because you can just solve. So if you do it from here, I'm going to use the quadratic formula because it's got a decimal and a 29 and it's prime. So right away, I know that it's going to be easiest to be using that quadratic formula. So my A here is -16. My B is 29. And my C, it's already over there, is 4.5. So when we identify these, we just have to make sure they go into our formula. And I'm going to do the discriminant part first. Okay, remember that's the stuff under the square root. So that's the b squared minus 4 times a times c. I'm going to do this part first, only because it makes it easier to put it back in later. So b squared, so I have -16, and remember that'll go in parentheses squared. And then I get minus 4 times -16 times 4.5. So if you enter that in your calculator the correct way, and you enter it with the parentheses and everything, you will get 1,129. That's your discriminant. That's what going under this part. And what's nice is this is actually going to end up being a perfect square for us. So let's just go ahead and look. This is our discriminant. So remember, now we have our negative. We're going to do our whole entire formula. So that we get negative b. So negative, and then b is 29. And then we have plus or minus. And remember what we just figured out was this part, the discriminant, 1129. And then we're going to divide it, the whole entire thing, by, well, it ends up being 2 times a. So 2 times -16, which is -32. So this is one answer and the other answer. You have to plug them both in. So just showing you, the first one you could plug in is -29 plus the square root of 1129, all of that divided by -32. Okay, that's with just the plus sign at the top. So when I do that, I get this number of -0.14. Remember, we cannot have a negative number. So it's not going to be that one. We just have to find out how many seconds then. You can't have -14 seconds for a ball to drop. So let's try the other one. Again, it's -29. And this time, instead of the plus, we're going to use the minus square root of 1,129 and divide all that by -32. So then I do the top part first, and then I divide by the bottom part. And that actually gets us a positive 1.95. So you could have said it took 1.9 seconds or about 2 seconds. Okay? So looking at this part, we're going to go on to the back, which is the last part of the open response in our targets. I want to just remind you, we have learning target. This was either 2.8 or it could have been 2.7, depending on your teacher. We renamed them this year, but it doesn't really matter. The target is evaluate graphs and discriminant. So we already know about the discriminant and how to find it. So looking at this, checking the type. So it's really easy when it's in standard form when we look at this and we do the discriminant, okay? We just plug that discriminant in. So you do B, so A equals 1, B equals -4, and C equals 4. So when we plug that in, we end up with -4 squared minus 4 times A times C. Remember, this is the discriminant. All we do is that B squared minus 4 times A times C. This is the discriminant. So once we figure all that out, we can come up with a couple different answers. This one happens to be 0. And if you recall, if it's 0, that means you're only going to get one answer, and it's going to be a real number. So that's what it tells us. That's why we use the discriminant. So let's look at 11. So again, I'm going to pick out our A, B, and C. So A is 1, B is -4, and then C happens to be 8 this time. And again, we're just going to plug it in. So I get -4 in parentheses, and then I square it, -4 times A times C. And if I put all this in my calculator, I get a -16. So if you recall, because it's under a square root, if you get a negative number, you are going to end up with complex. And if it's a whole number here that's, you know, an integer, you're going to have two solutions, because you're going to have that -b plus or minus, and then you're going to be pulling numbers out. So the negative tells us this is complex, and then the reason it's an integer, that tells us there's going to be two solutions. All right, and let's look at 12. So again, A equals 1, B equals -4, and C equals -2 this time. So I want to make sure I put it in right. So I do B squared minus 4 times A, which is 1, times C, which is -2. When I plug all this in, I get a positive 24. Remember, a positive number means we have two, and they are going to be real solutions. Okay? Those are some things to remember. And then we have sketching possible graphs of the function of a discriminant. So if we had, for A, if we had 36, you could possibly look at, you want to make sure we're sketching something and that it would go through maybe something like this. It's going to be at the bottom. It's going to open up. Again, these are in our note packets, our very last note packet that we did. So make sure we're using that as well. There's a couple good examples on there that we did, just showing what the sketches of the graphs look like for each one. And then also just making sure when you find these different ones that you know sketching it is not as hard as it looks. So we just remember for these opens up. And then 0, if you recall, 0, we're going to have something that is on 0, right? And it's going to open up if it has a discriminant of 0. It could be, it just depends on where it's at, but you just have to remember it's on the 0. Again, with the 36, it's going to be underneath here in these two quadrants, it's going to open up. And then we have -36. So remember, when we have negative, again, that's going to be above this, the x-axis. It can't be 0, so it could be anywhere like this. And then, again, we're looking at, for a negative, there's two answers. So we have to make sure we have two sides here. So, again, it opens up. Okay? And then let's go to 13, where we have the focus and the directrix. Okay? So whenever we have the focus here, that's a -2, we have a 0 and a -2, we know that it's going to open down. So a sketch could be like this. If I just draw it, it might be something like this. And here is 0, -2. That's the focus. Okay? And then we will make sure to look at this one that has a focus, again, 0, 3, but the directrix, sorry, I keep saying that wrong, directrix is -3. So what happens there is, now we have another one, but we have to make sure we want the sketch of the graph. So it's going to go something like this, and the line, this part goes up through there, And we make sure this one opens up because right here. And then the last one, same thing kind of deal. So the focus, I'm just looking at it and we have a negative number. So that's going to tell me right away that's going to open down. And we're going to go something like this to be down. It doesn't have to be perfect, but we're just looking at, we know what makes something open up or down, meaning the focus for this part. That's the explaining the reasoning. So if you said this opens down because the focus is 0 and the y coordinate is -2, that would be a reason why it opens down. Okay? All right. So that should serve as a pretty good key review, practice, redo this as many times as you need. I can give you blank copies for your Unit 2, Part 2 or Unit 2B. The multiple choice and the open response. This helps with both. The open response is a little bit more tough, but this is a great review to use and practice so that you're ready for that. If you didn't do so well and we're letting you make some corrections, again, this is a great resource to use to help yourself on it.